Hello, and welcome to Shiksha DaCosta. Today we're going to review our unit on solving quadratic equations. In this unit, hopefully you learned to expand and simplify quadratic expressions, to solve any quadratic equations, and made a connection between the roots of a quadratic equation to the graph of that corresponding quadratic. You're successful when hopefully you can do all of these things. You can pose a problem that involves quadratics that comes from real life and is given to you by tables of values and graphs, and then solve that problem. Or maybe you can represent a situation using a quadratic expression and then expand and simplify it. Hopefully you can also factor quadratics that have one variable by choosing the best strategy and then solve quadratics by applying a factoring strategy. Finally, did you figure out what is the connection between the factors used in solving a quadratic and the x-intercepts? And if that quadratic is not factorable, did you learn how the quadratic formula was developed? And do you know the connection between the real roots of a quadratic and those solutions that the quadratic formula gives you? And finally, what is the best strategy to use in any given situation? What are the advantages and disadvantages of using all those different strategies to solve or to determine the real roots of a quadratic equation? So just at the beginning of this unit, we realized that linear relationships are really easy to deal with in real life, but not everything in life is dealt with linearly. Sometimes when one quantity increases, the other one increases by a larger and larger amount. And in this unit, we studied one of those types of relations called a quadratic relation. Um, Working with quadratics requires a lot of algebra skills. In our first real lesson, we realized that, hey, if we have a graph, many problems we can create. If we create a graph of it, we'll get a shape called a parabola, and that is the graph of a quadratic relation. You can solve those problems when you model them with a quadratic by either finding the maximum or the minimum, by looking for the y-intercept, or maybe even the zeros. If you have the equation and not a graph, you can always use graphing technology like Desmos to graph that relation and find what are these useful points. Sometimes an equation is written like this with this f bracket x. This is called function notation, which we didn't cover in this unit, but which we will ideally study later. What you can do for now is just treat that just like a single variable, just like y. So just change it back to y and then continue on as usual. When you have a situation in real life, you can model it using quadratic relations. Once you have created that algebraic expression, it may look really complicated until you simplify it. Simplifying involves expanding all the brackets and collecting any like terms, and finally rearranging the terms from the highest degree, so the exponent has to be the highest, to the lowest degree. When you are multiplying two algebraic expressions together, what you do is multiply each term in the first expression by each term in the second. And in the lesson where we learned how to represent quadratic situations algebraically, we looked at binomials. So if we were to apply this rule, the quick and easy way to remember it is FOIL. We multiply the first two terms, the outer two terms, the inner two terms, and finally the last two terms. And then we add all these together. And that right there is how you expand a binomial. The opposite, or the reverse of expanding, is factoring. And factoring is a little bit more complicated. To factor a trinomial, which is an expression that has three terms, or in other words, a quadratic expression, the first thing you should always do is try to divide all the terms by the greatest common factor. And that usually makes your life a lot easier. Then finally, there's a little flow chart to apply the best strategy. For example, if it's a difference of squares, then just it'll look like this, and all you have to do is factor that into a plus b, a minus b. If it's not a difference of squares, well, then check if the a value is 1. In other words, does it look like this, where the coefficient of x squared, which is usually a, if that's just 1, then it won't even appear here. And if that's true, just use the sum product rule to factor it. If it's not true, you can check if it's a perfect square trinomial, although that involves a little bit of work. And if it is, you can just use your perfect square trinomial factoring, remembering that the sign in the middle is always the same as the sign over here. And finally, If that doesn't work, you can use decomposition to factor a factorable quadratic. To solve a quadratic equation, though, we can't just isolate x just like we would do if this was linear. Instead, we make one side equal 0, and then you find those zeros of the resulting quadratic that's on the other side. If the quadratic is factorable, you can quickly factor it, and then each of those factors, we can make them equal to 0 and then solve for x. But if it's not factorable, then we have other strategies that we have to turn to, like graphing or even something called a quadratic formula. So what does that mean? If you checked if it's a difference of squares and you said, no, it's not, then we can't use this strategy. Then you check if, like I mentioned, if a is equal to 1. If it's yes, then use the sum product rule. If it's not, we check if it's a perfect square trinomial. And if it's not, we check if there are two factors of a times c that add up to b. So this is the check to see if decomposition would work. But if that's not true, we have to turn to the quadratic formula to solve that equation. We can't solve it by factoring. The solutions to a quadratic equation, or the roots of a quadratic equation that looks like this, can be determined by using this formula, where here a, b, and c can just be plugged into here, and that tells you what the roots are. This is a way to calculate the roots without graphing or factoring. And you can solve, even if you don't want to use the quadratic formula, you can still solve a quadratic without graphing or factoring, but there are some conditions. It needs to either be in vertex form, or there shouldn't be any x term. So it should just be ax squared plus c. But this is rarely the case. So if this is the case, then certainly you can try isolating, but if not, the quadratic formula will always do you well. The zeros of this ax squared plus bx plus c equals 0. What the zeros of those equations will be the solution to when that actually equals 0. So the first thing you should always do is move over all of the terms until you have an expression equaling 0, and then you can just take a, b, and c, throw them into the quadratic formula, and that will give you the solutions. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.